Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over the solutions to the practice test for the CLEP College Algebra. This is just a brief coverage of some of the concepts that are covered on the test. If you want a much more comprehensive coverage of what is going to be on the test, feel free to go to the clep.collegeboard.org website. They have materials there for sale to help you adequately prepare for the test. Okay, so let's go ahead and go over 5 questions that highlight some of the concepts that are included on the college algebra test for CLEP. Let's take a look at question 1. It says, which of the following is equal to a raised to the bc for all values of a, b, and c? So this problem is testing your understanding or recollection of the properties of exponents. Okay, so I'm going to go over the properties that are applicable to this particular problem. Okay, so the first one I want to highlight is the power property. The power property states that if you multiply 2 exponents of the same base, you simply add the exponents, okay, with the same base. You have the base raised to the sum of the exponents. You also have the power, this is the product, sorry, this is the product property. We have the product property, and then we also have the power property. So for the power property, that just simply means if you have an exponent raised to a power, you simply multiply the powers. Okay? Now, if you take a look at these two, which of them do you think is applicable to this expression right here? We have a to the b, c. Using the power property of exponents, I can express this as a to the b raised to the c power. Okay? So we can clearly see that in this problem, the correct answer is option letter D, because the power property tells you that if you raise an exponent to a power, you simply multiply the powers, a to the bc, and this will be the expanded form, which matches this term right here. Okay? Now, if you take a look at option B, this is the product property. If you expand this, you have a to the b times a to the c. And we can see that this is different from what we have up here. Okay? So our answer is option letter D. Let's take a look at question number 2. Question 2 assesses your understanding of the components of the equation of a line. In this case, if you look at options A, B, C, D, E, these are the point-slope forms of the equation of a line. So do you really understand how the different components of the point-slope form, actually the slope-intercept form, this is the slope-intercept form. Do you really understand how the different components of the slope-intercept form affect the appearance of a graph? So if you have y equals mx plus b, m is the slope, and b is the y-intercept. Okay? The reason why I chose this form is because it is consistent with 4 options that we have here. Now let's take a look at the problem. It says if a is greater than 0 and b is greater than 0, which of the following could be an equation of the line graphed in the xy plane above. Now we have this graph here. Anytime you're dealing with arbitrary cases of an equation of a graph, you're given variables like this, it is beneficial to pick a value that satisfies the inequality. Okay? Since a and b are greater than 0, we can pick any value that satisfies that condition. Okay? So let's say let a be 1 and let b be 1 also. Okay? Now, if you take a look at this line right here, what do you notice about M and B? Since the line is going up from left to right, the slope M has to be positive. Okay, M has to be positive. So if you look at the options that we have, M is occupying the A position. Okay, so if M, which is the slope, is positive, that means A has to be positive also. So A could have a value of 1. Okay? All right. Now, let's shift to the B component. Okay? We know that B is a positive number since B is greater than 0. If you look at this graph, the y-intercept is in the negative y. Okay? So this should be something like negative 1. If we wanted to create the equation of our line, which equations here meet those expectations? So we have a positive slope, y equals 1x, and a negative y-intercept. So we have to put negative 1. Okay, so this is an example of an equation that meets this description right here. So this equation basically tells me that the A piece will be positive and the B piece has to be negative. All right, so if we plug this unique case back to the original condition, our answer should look something like y equals ax minus b. All right, this guarantees a positive slope, which means the line is going up from left to right. You're going uphill, and a negative y-intercept. The graph intersects the y-axis at a negative value. Okay, so if you look at all the options you have here, we can clearly see that our answer is option letter B. Okay, if you look at option C, this will be something like this. Let me just go over each case so that you can really understand what's going on. For option C, you will have a positive y-intercept. You have something like this for option C. For option A, since the slope is negative, the line is going to be going downwards because of the negative slope. For option D, the line will be going downwards, but the y-intercept will be positive, as you can see here. So this is an example of a line that matches option D. For option E, the y-intercept will be 0, and the slope will be positive because the product of two positive numbers is a positive number. So the line will look something like this. A line going up from left to right, intersecting the y-axis at 0. Okay, going through the origin, the slope will be bigger because, well, it could be bigger, it could be closer to 0 depending on the size of A and B. But the bottom line is it's going to be going up from left to right, and it should intersect the origin. All right, so the only graph that fits this description and this graph right here, the only equation that fits these two descriptions is option letter B. All right, let's take a look at question 3. This is assessing our ability to compose functions and evaluate our composite function at a specified value. Okay? Now there are two ways you can find out the value of this composed function evaluated at a point. You can compose the two functions and then evaluate your result at the point, or you can start from inside and work your way out. All right? I'm going to do the latter. I'm going to start from inside and work my way out. All right? We have f of g of negative 3. Let's start from the inside. G of negative 3 is what? What is g of negative 3? So let's figure that out. G of x is the absolute value of x minus 3. So if that is g of x, g of negative 3 simply means I'm going to plug in negative 3 into wherever you have x in this equation. Okay? So if we do that, we'll have the absolute value of negative 3 minus 3. That equals absolute value of negative 6. Final answer is 6. Okay, now we know what g of negative 3 is 6. So f of g of negative 3 is equal to f of 6. Now what is f of 6? Well, we need to know what f of x is in order to find the value of f of 6. So f of x is x plus 3. So f of 6 is 6 plus 3. Final answer is 9. Option letter E. Okay, so this is one way of doing it. The other way of doing it, you just simply plug in g into f. So you find f of g of x. If you do that, you have the absolute value of x minus 3 plus 3. And then you find f of g of negative 3, which involves plugging in negative 3 into this expression. You have negative 3 minus 3 plus 3. You have absolute value of negative 6 plus 3, which is 6 plus 3. And your final answer is 9. Okay, so whichever method you like, you can go ahead and use that method. All right, let's take a look at question number 4. It says, in the xy plane, the graph of the function f of x equals x squared plus bx plus 4 does not intersect the x-axis. Which of the following must be true about b? In this problem, you have to recall that we are taking a look at a special case of the solution of a quadratic equation. If the function, a quadratic function, never intersects the x-axis, that means you have imaginary solutions. Now, how do you determine if the solutions to a quadratic equation are imaginary? Well, you look at the discriminants, the portion of the quadratic formula that is underneath the square root symbol. Okay? So if you do not remember your quadratic formula, let me refresh your memory. X equals negative b plus or minus the square root of b squared minus 4ac, and everything divided by 2a. Now, this portion helps you determine the nature of the roots or intersection of the related quadratic graph. If this expression right here, known as the discriminant, if the discriminant is 0, you have a double root. If it's positive, you have 2 real roots, and if it's negative, you have two imaginary roots. Okay? So let's just call this. If this is less than 0, you have imaginary solutions. If the discriminant is equal to 0, you have a double root. And then if the discriminant is greater than 0, you have two real solutions. Okay? And this can be broken further into rational, irrational, based on what the value of this discriminant is. Is it a perfect square or not? Okay? Now, since it does not intersect, we have imaginary solutions. So the discriminant must be less than 0. Okay? Now, let's rewrite the function in equation form, the related quadratic equation for this function, x squared plus bx plus 4. We can even write it in functional form. Now, if you look at this, a is 1, b is b, and c is 4. Okay? Remember, the standard form of a quadratic is ax squared plus bx plus c. All right? We do not know what b is, but a is 1 because you have a 1 here, and c is 4, as you can see. Now, to find out what condition satisfies this situation here, we have to set up an inequality or equation. If we have no intersection, we said that the discriminant must be negative. So b squared minus 4ac has to be less than 0. Now we are going to plug in the values of a, b, and c into this inequality and solve. Okay, so b is b squared minus 4, a is 1, and c is 4. This is less than 0. Now let's solve this inequality. We have b squared minus 16 is less than 0. So let's get b by itself. We'll add 16 to both sides. That yields b squared is less than 16. Now how do we isolate b? We take the square root of both sides, and that yields the absolute value of b is less than 4. Okay? And this can be written as -4 is less than b, and b is less than 4. Okay? Anytime you have an absolute value quantity and a less than, it can be written as a bounded inequality. All right? So our answer to question number 4 is option letter C. Okay, so B is between -4 and 4 to guarantee that you have imaginary solutions, which means that the graph never intersects the x-axis. Okay, let me give you two possible scenarios. If you have a graph like this, a quadratic looking like that, this has imaginary solutions because it never intersects the x-axis, and then this one right here also. All right? Okay, let's take a look at the last one. It says, which of the following product is a real number? Now, there's a cool trick for this problem that requires you to do no work whatsoever. If you have two expressions of this form, a real and imaginary part, two complex numbers, if they are conjugates of one another, then their product is guaranteed to be real. Okay? So what is the conjugate of a complex number with both pure and imaginary parts? If you have a plus bi, all you do is invert the sign of the imaginary part. Okay, so a minus bi. If you multiply these two together, you have a squared plus b squared, which is a real number. All right? So if you look at all these options right here, do you see an expression where only the sign of the imaginary part is inverted? Let's see. This option A is perfect because if you notice, the ones stay positive and the sign of the imaginary part is inverted, so this is great. In this one, none of the signs change. That's no good. In this one, both of them change. That's no good. In this one, both of them are identical, just like here. No change. And then in E, the real part changes and the imaginary part changes also, which is unacceptable. It is only the sign of the imaginary part that can change to guarantee that your product will be real and that you have um, two conjugates, okay? A complex number and its conjugate. Now let's go ahead and show you that our answer is in fact correct. We're going to find the product of these two complex numbers and see if our result is real. Okay, so we're going to expand this. 1 times 1 is 1. 1 times negative I is negative I. Positive I times 1 is positive I. Positive I times negative I is negative I squared. Now you must recall that I squared is equal to negative 1. Alright, so if I apply that here, I'll have 1. The middle terms cancel out. Negative I squared becomes negative negative 1, which is 1 plus 1, which is 2. This is real because it does not have an imaginary piece. So we can clearly see that our answer is option letter A. Thanks so much for taking the time to watch this presentation. Really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials ranging from algebra all the way to calculus. If you have any questions or comments, include it in the comment section below this video. And feel free to visit our website, math.serve.com, for a wide variety of tutorials to aid you in mastering your math class. Thanks again for watching and have a wonderful day.